Pete began as a physics student and astronomy student, has a PhD in astronomy. He was a brigadier general in the United States Air Force, retired now. He was director of NASA Ames Research Center. He has a number of stories from all of these different positions that he's held over his career. And it's easy to discover when you speak with Pete that he is indeed an expert in science and in space, civilian, military, history, so many things. So I'm eager to see what he's going to present to us tonight. Now, I have to tease you a little bit, those of you who are our students here this summer. There's something special that Pete may be discussing tomorrow, and it has to do with something that he said at Ames once, and it relates to something special that could happen on the moon. And I'll let him elaborate later, but just be sure and be staying tuned to that tomorrow. We're going to hear some things this evening that might not be related to that, but there could be something exciting tomorrow about, I heard it as something like a bombing run on the moon, but that must be wrong. It must be wrong. But we'll find out later. Pete, please, I'd like to welcome you to our stage and turn the microphone over to you.
Thank you. It's really good to be here. I've been involved with ISU since the third SSP, which was held in Toronto. A little younger then, I didn't have a cane, much better looking. But anyway, I'm delighted to be here tonight to talk about a topic I think you'll find interesting. This is what I do most of the time, is look for life in the universe. And of course, one of our key projects, which I'll talk about, is aliens. And no, I'm not going to tell you we found any, but we thought we might have a few years ago. I'll talk about that. But without further ado, let me move forward. Let's see. The first thing is, I used to work for the U.S. government, and since our foundation in the United States, I have to say here that there's nothing sensitive or export control in my talk. So with that caveat, my assistant, who's a lawyer, is watching to make sure I don't get in trouble. Well, let's start with aliens. You know, this is a topic that everybody finds really fun. And there's sort of two views about aliens. You know, one is they're really nice, and they come in peace. The other one is they're not really nice, and they come to do horrible things. Now, I haven't the slightest idea if there is aliens or there are aliens and what they are, although I found this cartoon a few days ago that sort of says my thoughts about it. In fact, I'm going to talk about finding intelligence in the universe, and usually when people ask if there's intelligent life in the universe, I say, well, the bigger question is there intelligent life anywhere? And I usually say that it's more likely to find it the farther you are away from a national capital. Although a couple times I've been in national capitals and there's people from the government that frowned. But we're not that close to Seoul, so I think we're in good shape. I'd also like to talk a little bit about this is a picture taken a long time ago as well. I think it was in 1999. You may recognize the guy on your left. That's Arthur C. Clarke. I think he was the first chancellor of International Space University. And this was a picture that I went and visited him in Sri Lanka. It was right after the ISU summer session in Thailand. And he, you know, I had been in contact with him before, but he became really my lifelong mentor. I've got a little story about this picture in a second, but my favorite quote from him said there are two possibilities that exist. Either we are alone in the universe or we are not, and both are equally terrifying. Now, there's another reason I put this picture up, because the three of us, just wrote a paper and got it published in the Journal of the British Interplanetary Society, including Arthur C. Clarke. And you might ask, well, how do you do that? And this is an interesting topic about aliens because we resurrected Arthur on ChatGPT. And we had him write a paper about the possibilities with us, about symbiosis of Earth and Martian life. And we published it in the Journal of the British Interplanetary Society. But we persuaded them to make him an official co-author. And of course, that's more complicated than you think, because most journals don't want to do that, because, and those of you that study legal things, is that AI entities don't have agency nor responsibility. Now that's for now. So, one of the answers about where the aliens are is they've all become AI creatures like we will in the future too. But I commend you to see that. I think it's one of the first times that a journal actually accepted, a referee journal, a AI entity as a co-author. Now, I represent the Breakthrough Prize Foundation. The thing that they do that most of you have probably heard about is the Breakthrough Prizes. These are the world's largest science prizes. They're given in fundamental physics, mathematics, and life sciences. They're $3 million US. It's about 3 times the size of some Swedish prize I'm not supposed to mention. But it's been given now for about 15 years. It was funded by a number of high net worth technologists, basically, including Mark Zuckerberg, Sergey Brin, Andrew Zwisky, and the founder that is my primary sponsor is Yuri Milner. The reason I want to mention this is, in addition to the main prize, we give early career prizes in physics, mathematics, and several other topics. But there's another prize we give, which is a junior challenge, and this is kind of fun. This is for young people between the ages of 13 and 18 that we ask every year for them to write or to produce a couple-minute video on some science principle. The winner gets a $250,000 scholarship wherever they want to go in the world. The school gets a $200,000 laboratory that our sponsors pay for. But to me, one of the neatest things is the teacher that inspires the students gets a $50,000 check. And the first person that won that, the young man in the upper left, he didn't tell the teacher he'd nominated him. And so the teacher was kind of sitting quietly, and we called the teacher and said, "Where do we send your $50,000 check?" And the first thing he says, "Is this a call from Nigeria?" So we persuaded him no, there was a real check, and we finally got it to him. Although that's a good scam, I should think about that. But to me, it's interesting. These people have been from all over the world, places like Mauritius, Philippines, Peru, India. So it's really a global prize. If you know younger people that are interested in this, please commend them to apply for it. Now, the Breakthrough Initiatives is the research arm of the Breakthrough Prize Foundation. And in 2015, we announced 3 major programs, and I'm going to talk to you about those programs tonight, with the Royal Society in London. And what was really kind of cool is our science advisor until he passed away was Stephen Hawking. And a really neat person, and it's a real loss that when he finally passed on. But he was at our initial announcement, and it was kind of a pretty cool event. Now, there's 3 fundamental questions about life. And I mentioned the first one, is there intelligent life anywhere? The second is probably even more fundamental, is there any life? And just to remind everybody, we don't know of any life off the Earth right now. And the third one, which is, I have to confess, it's my favorite project, but and I'll talk a little bit about it, but we've put this one on hold for a while, but can we travel between the stars? And this is a kind of a real science fiction question, and I'll address that, is what can be done with technology we understand. Now, the first of our projects is looking for intelligent signals. This is called Breakthrough Listen. It's our sponsor committed about $100 million for a 10-year project. We are now in the second phase of that with an additional $40 million. What we're doing is using mostly radio and optical telescopes to look for an intelligent signal, which we call a technosignature. It's evidence of a technological civilization elsewhere. This program has been using most of the major radio telescopes and a lot of the big optical telescopes on the planet. And there are efforts in every continent and been ongoing. As I mentioned, we're using the most modern instruments that are available, both optically and radio. That includes the FAST, the 500-meter telescope in China, the new square-kilometer array in South Africa and Australia, as well as a large number of other optical and radio antennas. The program is now headquartered at the University of Oxford in the UK. If any of you are looking for graduate places to go to school, Oxford has a great program in physics, but there's a special effort in technosignatures. So if you want to actually study looking for aliens, you can get a DPhil degree from a pretty reputable university, I'm told. But I'd commend that program. Please talk to me later about that. Now this is the Parkes Radio Telescope in Australia. It's 64 meters in diameter. It's an old radio telescope. It was built in the early 1960s. It's also a very famous radio telescope because it was used to receive the Apollo 11 moonwalk data. And in fact, there's a great Australian movie. It's a family movie, so don't worry about taking your parents to it. It's called The Dish. It starts, I think, with the crew playing cricket in the antenna dish. So, but the reason I put it on here is about four and a half years ago. It was actually Halloween. The principal investigator called me and he said, "I think we have a signal." I said, "What?" He said, "No, it's a technosignature signal, and it matches all the things that we were looking for." And I'll show you the signal later. And I said, "Wow, you mean, you know, I can go back and tell the billionaire that spent all this money that we might have made it a success?" He said, "Well, don't say anything yet." And so I opened a bottle of champagne, figuring I'd get a big promotion. And I finished the first bottle, and I was about to open a second. And he called me back, and he said, "Now, look, I need to tell you that most of us think this is probably interference. It's radio interference." And I said, "Okay, well, how many people know about it?" He said, "Well, there's 9 people that were involved in the project." And I said, "Okay, tell everybody, don't talk about it until we validate what's going on." 2 days later, this headline appears in The Guardian, maybe not that reputable of a newspaper, but it was picked up everywhere. So if anybody thinks that people can keep things secret, rubbish. So that's one of my first messages, is that to think that somebody has secret data about aliens, I think is just wrong. Now, it may mean that I just don't know. But the interesting thing is this signal came from the very nearest star, Proxima Centauri, and I'll talk more about the system it's in a few minutes. But what's interesting about that star system is that just about 6 months before this signal was discovered, the astronomical community identified 2, and there's now 3 planets orbiting that star. 2 of them are Earth-size, and they're in the habitable zone. So my first thought is, wow, there might be even intelligent aliens right nearby. Both a good and a bad thing. But at any rate, I want to show you the data. I won't go through a lot of details, but the picture on your left is what's called a waterfall diagram. And that's on the vertical axis is time, on the horizontal axis is frequency, and the strength of the radio signal is that is given by the color. So white color or yellowish color is a stronger signal. The red line is a calibration piece of data. But the interesting thing is you'll notice there's a yellow streak at an angle. First of all, it's a very narrow streak, which indicates it's a very narrow band frequency, which is what we would expect from an intelligence signal, because natural astrophysical phenomena don't produce narrowband signals. Second, it's at an angle, which indicates it's drifting in frequency, which shows us it's off Earth, so it's somewhere else. Presumably, it's something that's traveling at different velocities. The other thing you'll notice is there's little bands horizontally in that. As we tracked Proxima Centauri, we rocked the telescope on and off the source. That showed us that Proxima Centauri actually is the source. So we got very excited. Although we examined this data in detail over the next 2 or 3 months, and we concluded that this is almost assuredly interference. There were other signals at this period of time. It was a new detector on the radio telescope. So it was an interesting thing. It was probably the most compelling idea that there was actually a signal since the so-called WOW signal from the 1970s. The cool thing about it was the data was taken a year and a half before we looked at it, because there's a lot of data and nobody has time to look at it. It was actually an undergraduate student that found this. He was in our summer program, and the scientific leadership had said, okay, here's what you look for. And about 3 weeks later, he came back and said, is this what you were looking for? He thought we had planted this data, but he led the analysis, and in the end, it was published in Nature Astronomy. You know, in astronomy, being in Nature Astronomy is like being on Rolling Stone in the rock industry. And he was the principal author. And for an undergraduate to be a principal author in Nature Astronomy was pretty cool. He had no trouble getting into graduate school with full ride scholarships. But it was kind of a neat result. But it did convince us that we have a problem with interference. Now, the answer to interference is go someplace where the interference isn't. And because in this room, everything is radiating. Your cell phone is radiating into these frequencies. You know, the lights, the cars along the street. And it's very hard to get away from them, even in the most remote parts of Australia where the square kilometer array is being built, the low frequency one, there's interference. Right now, the best place we know about is the far side of the moon. And this is not going to stay radio quiet for very long because there's a lot of activity in the moon. In fact, some of you are figuring out how to make more on the moon. You know, stay away from the far side for a while at least. But this, we finished a major study this about the last few months. We had a major conference at the Astron Radio Observatory in the Netherlands, and we concluded that we can put a radio telescope with private money, and I want to emphasize that all this is private philanthropic money. We're not looking for government money, although if you want to give us some and you're a government, we're happy to take it. But this study will be out soon, and we hope to sometime in the next 5 years to put an initial radio telescope where it's not interference with. Anything we see will be something very exciting, whether it's astrophysical or a technosignature. Well, let me now turn to the other question: is what is there? Where is there to go, and what is there where to look for? Now, my favorite star system is the Alpha Centauri system. It's the nearest star system. It consists of 3 stars, so it's not boring like our solar system, just 1 star. We have 3 suns. 2 of them are about the size of the sun. One's a little bigger, one's a little smaller. They orbit around each other in about 80 years. If we were orbiting Alpha Centauri A, the biggest star, kind of where we are, 1 astronomical unit, that Alpha Centauri B would be somewhere between the orbit of Saturn and Neptune. And it would be very bright, but it wouldn't produce much heat. Now, that star system also has a distant 3rd star. It's Proxima Centauri, and it's 10,000 times further away from the other 2 stars as the Earth is from the Sun. And it wasn't even recognized for sure until about 20 years ago that it was actually orbiting the other 2 stars. It's a red dwarf star, which means it's about 1/10 the mass of our sun, but it only has about 10,000th the energy output. And that's the star that we've now detected a number of planets around indirectly, which you see the reflex motion, is the planet orbits the star also orbits the planet, and so you can measure the Doppler shift, the radial velocity of that star, and you can see evidence of these three planets. So kind of a neat system. It's also a little older than our solar system. So the So we started the Breakthrough Watch program specifically to study the nearest star systems, and particularly Alpha Centauri. And it was interesting that we started this program before we knew there was any planets in this system. But then about a year later, the European Southern Observatory announced that they had detected initially 2 and later 3 planets. They were nice enough to invite me to the press conference. We were nice enough to give them $5 million to do some research. And at that time, it was one of the world's largest telescopes, still is. And they had an artist's conception of what it might look like if you were on one of these planets that was Earth-like. Unfortunately, I showed this picture to our sponsor. It was also funding at the time efforts to go there, and he said, well, we already have a picture, why do I want to send a probe? So be careful what you ask artists to do. But anyhow, I kind of like this picture, because you can see the red dwarf star it's orbiting, and in the distance you can see the other 2 stars that are very bright and quite visible. Now, we had 100 hours of time on this telescope. This is the VLT, the Very Large Telescope in Chile. There are 4 8-meter telescopes in the same complex. Now, I have to pause here and say that I'm an astronomer, so I'm embarrassed at our inability to have good names for these things. This is the Very Large Telescope. They're building a new one, which is a 39-meter, which is called the Extremely Large Telescope. Initially, and I kid you not, it was supposed to be a lot bigger. It was supposed to be maybe 70, 80 meters, and it was going to be called the Overwhelmingly Large Telescope. So, you know, some of you can do better at names than VLT and ELT. But at any rate, we had 100 hours of time with a special instrument that can actually image, not just measure the radial velocity. So you could actually see a planet orbiting. It's an infrared imager, so it sees in heat, basically, rather than in visible light. That's an ideal place to look for planets in the habitable zone that are like the Earth's temperature, because that's where the peak of the Earth's radiation is, and it's a lot better contrast. If you try to see a planet orbiting a star like the Sun that's many light years away, the planet by reflected light is 1 billion times fainter than the star. It's only 1 million times fainter in the infrared. Now, I put this picture up because we tentatively detected a planet orbiting Alpha Centauri A in the habitable zone. It was a giant planet, so it's sort of between the size of Neptune and Saturn. Now, that reminded us of something. And I'm a science fiction freak, so this is from the movie Avatar. And if you go and do a little geeky investigation, you find that in Avatar the Earthlings are going to Alpha Centauri, and there's a planet orbiting it in the habitable zone. That's a giant planet that, in this case, has moons, and one of the moons is habitable. I think that's called Pandora, and we thought this was pretty cool, so we told James Cameron about it in the hopes that maybe he'd give us money. But if you want to hear a little bit about what he had to say, he was their speaker at our annual conference. This was, during COVID, so it was online. But you can go to the Breakthrough Initiative's website, and you can look under our conferences, and you can actually listen to his talk. And what I find kind of cool is he talked about how he expected humans to actually get to Alpha Centauri, and it's actually, I'm going to talk a little bit about the technologies he talked about, because I think it's probably the right effort. Now, we have some more programs. The first one is a small satellite to specifically look very precisely at the 2 brighter stars in the Alpha Centauri system and measure the distance between them to within 1/1,000,000th of an arcsecond. And that's like, looking at I think it's something like a human hair at 1,000 miles. So it's a pretty accurate measurement. This one's being led by a group at the University of Sydney. We'll launch it here in about a year and a half. But this will be our first satellite program that we're doing. And it's pretty exciting. If you want to know more about it, this young guy sitting here, the former ISU grad, Kieran Groton is the project manager for that, so I'll let him answer the questions. We have another program that we haven't quite initiated, but we're looking at putting thousands of small telescopes that students could operate around the world. And what they would do is they would look at large parts of the sky to look for shadows of a planet going in front of the star. This is one of the ways to detect planets, that it's hard to see the planet, but against the background of a star, that you can see a small dip in the light. We put a few of the first ones in Bhutan. There's a long story about how I got to know the king of Bhutan, but this is a place we may put a lot more of these. Another program that we're doing is we have an effort. This is currently the world's largest single-mounted telescope. There are two 8.5-meter mirrors separated by about 20 meters that are at a telescope in Arizona. Using the same method we used in with the VLT, we can look in the northern hemisphere for actually directly imaging planets, and that'll be operational here this next year. Now, I put this picture up. This was taken with a large binocular telescope about a year ago, and another star that's near the sun, it's about 9 light years away, is Procyon. It's one of the largest, brightest stars in the sky, and they have tentatively detected something in the habitable zone orbiting it. It's also a giant object. It may be what's called a brown dwarf. A brown dwarf is something about 10 times the mass of Jupiter, which is still glowing from its creation, even if it was billions of years ago. And so their temperature is maybe 800 to 1,000 degrees centigrade. So they're not a self-luminous star, but they are producing a lot of energy. Now, the reason I put this up is I'm very excited, not only because of Avatar, but I'm excited about the general idea that places that we may look for life may not be necessarily on a planet orbiting a star, but on a moon orbiting a planet orbiting a star. So one of the ideas is if we find a planet orbiting these, can we detect a moon orbiting, especially a moon that might be the size of the Earth? This is called an exomoon. This is one of the exciting things in space science is how many Earth-like places are there that Earth-like life could exist. I won't go through all the details of it, but the Procyon is an interesting star. It's a lot younger than the sun. It's a little under 2 billion years old. At some point about 1 billion years ago, there was another star in the system that went nova, and it's now become a white dwarf. So it's potentially a habitable place that tells us there's a lot of neat places nearby that are habitable, including orbiting red dwarf stars. Now, for the future, we'll talk a little bit about some studies that have been ongoing, that once the Starship works, and if Mr. Musk spends more time, out of the White House and at his rocket pad, I think he'll get it working. It has the capability of launching really large payloads. So one of the studies we did was look at actually launching a ground-based telescope. This is one of the things that we've been looking at, and haven't made any decisions yet, but this is a 6.5-meter ground-based telescope mirror that we think we could launch into space at the end of the decade whenever Starship works. So stay tuned. There's a lot of private interest in doing things like large space telescopes. And these would be ideal to directly image and eventually determine that there really is life-bearing planets around the nearby stars. Now, let me turn to our solar system. This is Earth's evil twin, Venus. Most people think about life on Mars. I think it's more likely that we're going to find life in Venus, and I'll tell you why. About 4 years ago, there was a tentative detection in the upper atmosphere of Venus. Venus is at the surface, it's literally hellish. It's even hotter than it is here in Korea in the summer. It's about 500 degrees centigrade on the surface. The pressure is about 90 Earth atmospheres, so it's not a very likely place to find Earth-like life, at least. But at about 50 kilometers above the surface, the temperature and pressure is about exactly the same as it is in this room. It's sort of room temperature, room pressure. Now, one of the problems is that at that layer in the Venusian atmosphere, you're in the middle of the clouds, And the clouds aren't water, they're sulfuric acid, pretty pure sulfuric acid. But at that level in the Venusian atmosphere, there was a tentative detection of the gas phosphine. This was by radio astronomy. Phosphine is a highly toxic gas, but on Earth it is virtually always produced by life. So it's a very interesting potential detection, although a lot of people criticize this, but there have been measurements since then that have shown that it's more likely to be a real detection. Last year, another element or compound that is potentially indicated of life was ammonia, was confirmed in the upper atmosphere of Venus. So it's an interesting place that there might be organic molecules and potentially life. Now, one of the co-discoverers of this is Professor Sarah Seeger at MIT, and I'm not going to go through a lot of the details here, but she believes that life in Venus's atmosphere might not be based on water, but based on a different solvent. One of the things you look for in life to demonstrate there's life someplace are two things. One is a fluid that can act as a solvent, and we usually assume that's water, but it could be liquid sulfuric acid by the studies that she did. And second, you look for evidence of what's called a non-equilibrium gas. This is something that if you didn't sustain it with a life process would go away through some chemical process. For example, here on Earth, oxygen is a non-equilibrium gas. If we didn't have life here sustaining it, within a few million years, the oxygen would all be tied up in minerals on the surface. So if you find non-equilibrium gases like phosphine and ammonia, and you find a solvent, you might have life. So the idea is there may be life floating at this layer 50 kilometers in the upper atmosphere, right in the clouds. And one of the questions is, how do we prove it's there? Now, you can go to a space agency and ask to go to Venus, but if you tell them you're going there to look for life, they say, well, that's rubbish. So there's not any life detection missions going to Venus that are publicly funded, but there is a privately funded effort that was initially funded by Breakthrough Initiatives and then funded by Schmidt Sciences, another foundation we're working closely with. And Rocket Lab is going to launch this, we hope, in about a year and a half. And this drops a small probe into the atmosphere of Venus that will begin to look for more evidence of these non-equilibrium gases. Now, that probably wouldn't prove there's life there. So there's a possibility of a privately funded mission here right after the close of the decade to actually put a balloon in the Venusian atmosphere that would float around for weeks or months and would have a mass spectrometer which we could, and a microscope that we could really look and prove if there's life there or not. So there's another very exciting private effort. Now let me talk about, to me, what I thought was one of the most exciting things. We announced in 2016 Breakthrough Starshot at the New World Trade Center in New York. You see the announcement there, our principal sponsor, Yuri Milner, and this was Stephen Hawking's last trip to the United States. Freeman Dyson, who just passed away a few years ago, another visionary about interstellar travel. Anne Druyan, who was the creator of Cosmos series and the widow of Carl Sagan. Avi Loeb, who I'm going to talk a little more about, a professor at Harvard. Mae Jemison, a former astronaut who runs another foundation, and then myself looking stupid there on the other side. I hate that picture. Can't we get a better one than that? But if we want to go interstellar, you got to go pretty fast. If we went the speeds we go today in space, it would take 50 to 100,000 years. Probably not something I'm going to get somebody to fund, even a visionary billionaire. So we need to go about 1,000 times faster. So we initially asked Professor Loeb at Harvard to run a study, and his first reaction was not good. However, there was a professor at the University of California at Santa Barbara that had an idea that there was a way to do it, and it's sort of based on a very old idea that there's a letter from Kepler to Galileo that talks about sailing on heavenly winds. Now, there really are winds in space, but they're winds of light mostly. And so the idea was, if we could produce a really small spacecraft, one that was a few grams, and we left the fuel and the engine on the Earth, and we attached this ChipSat to a sail, and it was a light sail, then we use a laser beam to push it. And this actually looks like it might be able to work later this century. So we started a program called Breakthrough Starshot to look at it. Just to point out, this was a privately funded effort by the Planetary Society a few years ago that showed that light sails do work. They've since been used for a number of things, and I'll talk a little more about light sails before I finish. Now the laser becomes pretty big. In fact, it's 100 gigawatts. This is an artist's conception of the laser, and this is kind of why I think our sponsor put it on hold, because this is a really big laser. And there's a lot of issues about it, including policy issues. And since Alpha Centauri is in the southern hemisphere, the best place to put it would be in the Atacama Desert in Chile. And it would probably cost tens of billions of dollars at the minimum. But there's kind of a story behind this, because when we announced this at the New World Trade Center, the press asked me, and this is how I got in trouble for about the 50,000th time, is where would we put this thing? And I said, well, in Chile. Now, we made a mistake. We forgot to mention this to the Chileans. And so I've been summoned twice to Chile to talk to two different presidents of Chile. They were both very nice. They said, but next time you want to put some giant laser in our country, please ask us first. We'd be happy to help. But another message, if you're working internationally, don't mention countries unless you've asked them first. But this is an artist's conception that the laser would be, you take the light sail attached to a chip, it would be about 60,000 kilometers away from the Earth. You focus the laser on it. It's a very big problem because there's a lot of energy, 100 gigawatts. There are materials that can reflect that. And it accelerates at tens of thousands of Gs for a few hours, and then it's ending up 20% the speed of light, which it then sails for 20, 25 years, flies by the Alpha Centauri system, takes data, and sends it back with a laser beam. So it's a big challenge, but we think we can do it. Now, it was put on hold because of the cost, but one of the other questions is, what if you used a rocket engine instead of a laser beam? And now, if you use a conventional chemical rocket and you want to go to 10, 20% the speed of light, it takes the amount of fuel that would be the mass of the galaxy, so we're probably not going to do that. And a lot of that has to do with the efficiency of propulsion. That what's called a specific impulse is a parameter you use for, and you probably had that in your lectures, that chemical engines have a specific impulse of 300 or 400 seconds. And if you do the calculations, you really want 1 million. So we're off by quite a few factors of 10. With electric propulsion, you can get thousands. With fission, nuclear fission, if you could use a fission device, you get maybe 100,000. But with fusion, you can get close to 500,000. So this is beginning to get us to the place where we might actually be able to get efficient propulsion. And the reason I put this up, there's a company in California called Helicity Space, which is developing a fusion engine. If you watch The Expanse, they use fusion engines, so obviously we should do that too. But this is promising. I think in the next decade we'll begin to see working fusion prototypes at least. And I won't go into a lot of the details, but they're beginning to develop a prototype. It's in a laboratory in Los Angeles, and it does appear to be a workable approach, so we'll see. But the reason I put both these up is when we asked Cameron about how did they get there hundreds of years in the future, he said they use a laser to accelerate it to a few percent the speed of light, and then at the other end they use a fusion system to stop. And so I think the message I want to give you is that the technologies to get interstellar seem to be in reach this century for our species. Now I want to talk a little bit about another idea that this is another science fiction picture. How many of you recognize this? This is from Stargate Universe. and they haven't shown it recently. But it features some sort of alien starships that humans have figured out how to get on board, and they travel in another galaxy, and they're powered by diving towards the star and powering from the energy of a star. And this isn't such a goofy idea. There's something called a sun diver, which we've been looking at, that you can build a small spacecraft that's just a few tens of kilograms, and you deploy solar sails when you get into cislunar space. For those of you studying the aerospace engineering, it's a C3 of close to zero. You unfurl sails, and then you slow down, fall towards the sun, and the closer you can get to the sun and survive, the sunlight now, radiation pressure goes up as the square of the distance from or the inverse square of the distance to the sun. So if you can get to maybe a few hundredths of an astronomical unit, you can end up getting speeds that are tens of astronomical units per year to hundreds of astronomical units per year. This we can do now. The idea is you drop in towards the sun, get close, and then you speed out to some target in the outer solar system. And instead of taking decades to get to Pluto or Neptune, it takes a year or two. So this is a technology that we're very interested in. There's a prototype that NASA built. So this is technology we can do today. And I think it potentially gives us a way to get to the outer solar system, if not interstellar, much more quickly. Now, I asked our team, I said, supposing I wanted to send something to Alpha Centauri, and I didn't want to take 100,000 years, but what if a few thousand years? And it turns out that using just sunlight, we can probably get fairly substantial payloads that might take a few millennia to get there. So we're starting to get to the point where I think humans can contemplate interstellar missions. Now I want to talk a little bit about, this is Oumuamua, or at least an artist's conception of it. This was the first interstellar asteroid, the first thing we detected that we confirmed went or came from outside the solar system. There's another object right now that is just detected. It's the third one. The reason this one was interesting is that it has a very funny light curve. It has a huge change. And the assumption by most astronomers is it was this elongated thing. However, as I mentioned, Professor Loeb, Avi Loeb, he thinks, because he was in charge of the Starshot program, he knows what a light sail looked like. He thinks it's an alien light sail. Now, I think he's probably wrong, but at least it's an interesting concept. And he's written a couple books about it. You can buy his books. He makes money on them. We also discovered, using U.S. military data, that a small asteroid, something that probably only weighed a few dozen kilograms, was clearly interstellar, and it hit in 2014 off the coast of New Guinea, disintegrated, and we have pretty accurate positions of where this was within a few kilometers. So 2 years ago, Professor Loeb led an expedition, and they took a very powerful magnet and ran it along the surface of the ocean where this stuff supposedly landed, and they found things that might be metal from this meteorite. Now, he carries it a little further and says, well, it has funny compositions. Maybe it was an alien starship or interstellar probe that broke up. Unlikely, but not completely impossible. So this is another very interesting possibility that some of this interstellar material may tell us more. Now, hopefully later this century, we will actually fly by planets orbiting the nearby stars and begin to answer the questions, is there life there? But I think sometime in, many thousands of years, there will be life there because we're going to send it. And this is, to me, one of the more interesting questions, and I think the ultimate future of humanity. We have an annual conference, and the last one was held in April this year at Oxford. And this is, we talked about that what if the life that exists or the intelligence that exists is not like we understand it, and what if it's even artificial intelligence? So this is all online. You can see the the presentations. We have another conference we'll be holding later next year. So look forward to having more discussions with this. Well, let me stop there, and I'd be happy to answer any questions, other than the fact that, no, I don't know of any alien artifacts that are hidden away. I wish I did.
Pete, thank you so much. So you've given us a lot to think about here. And it's all things that we want to think about because we're excited about searching for life in other places. We're excited about interstellar travel. We're excited about doing new, different kinds of space exploration in better ways, maybe better ways. What questions do we have from the room?
Hi, thank you. It was an excellent presentation. I really enjoyed that. I wanted to know what you thought about planets or moons like Enceladus with a liquid ocean core for signs of life.
Well, that's a real interest. Is this on? Can you hear me? Yeah. One of the other programs we looked at was going to the moons of the outer solar system. We now know the number of these are ocean worlds, and of course, the initial one that was very exciting is Enceladus. It's a small moon of Saturn that, because of the Cassini mission, we know a lot about it. The interesting thing about Enceladus is it's not very big. It's only a few hundred kilometers across, but because it's close to Saturn, the interior of it's heated by tidal forces, and it has an ocean and an ice crust. And the interesting thing is the ice crust cracks. And Cassini looked at some of these geysers, if you want to use that word, and flew through some of their plumes and detected primitive organic molecules. Of course, these exist a lot of places. The question is, are there sophisticated organic molecules that have a complexity to indicate life? So this really kicked off a lot of discussion. We looked at sending a private mission to Enceladus. The trouble is Enceladus is a long ways away, and it takes a decade or more to get there, and they're expensive missions. There's another place in the solar system is Europa, orbiting Jupiter, and it also is a water world with an ice crust, and it also appears that the ice cracks occasionally, and there's water that's sprayed into space. The trouble is that, and we could get there a lot faster than Saturn. It's only half the distance. So we looked at a mission to fly through those plumes of Europa and see if we could detect organic molecules using it with a mass spectrometer, which measures what's the atomic and molecular species. It was cheaper. It was still hundreds of millions. But the trouble is that when we looked at these plumes, they aren't on most of the time. Occasionally they go on and they go off. And so I don't want to go tell a billionaire, I need 250 million from you to go to see Old Faithful in the outer solar system, but it isn't faithful when we flew by. Well, that's why it didn't work. So I think because a flyby mission is a lot cheaper, that's why we're looking at these missions like a sundiver, because those might only cost a few tens of millions. And so you could send a number of them, and you just fly through these places. So the answer is that there's a lot of places there can be life. And I just mentioned the upper atmosphere of Venus. I mean, obviously people think there might be life below the surface on Mars. But these water worlds or other places, even potentially the atmospheres of giant planets. So, there's a lot of exciting places in our own solar system to look for life. But that's a good point. You're a good straight man with it.
And we could use remote sensing techniques in many cases to do this. That seems really practical.
Yeah, absolutely.
Who else has a question?
Hi. I was just wondering, when we're looking for life, we're looking at organic traces or water or anything that we can relate to life as we know it. Is it possible to look for life as we don't know it? Like, would you be able to do that if I feel like we're looking at it from a biased view of this is what we need to live. But if everything is different in a completely different universe, could it be that we're just having a different lens that we should be looking through?
Well, that's exactly what this meeting this last year was, where we were asking that, you know, what about life as we don't know it? You know, how do you look for something you don't know about? And, you know, I think we had a conference a few years before we called Looking for Life in All the Wrong Places. And the first question is, what is life? And we don't have a good definition of life. And it's, so would you recognize it if it bit you? I guess that's sort of the old saying. But there are people beginning to look at that, rather than looking for organic chemistry as we understand it, let's look for complexity. Because it seems that when you look at any chemistry, that inorganic chemistry or other things produces a complexity to a certain level, but nothing more than that. Whereas all of the life processes, even strange ones, that we start to look at, like sulfuric acid-based life, has complexity. And so that's one of the things to really look for is to start thinking at different chemistries, even really exotic things. Can life exist in interstellar space based on chemistry you don't understand, or you know, energy, dust agglomerations? And that was one of the kinds of things that people discussed. It was really fun. Of course, the other thing is looking for, I mean, if you think it's hard to look for life, how do you look for conscious life or intelligent life? And that's really complicated now by the question of, you know, that we may see the emergence of an alternative consciousness on Earth with AI. Now, there's a big argument whether that's, can you create consciousness with computers? One of our speakers there was Roger Penrose, and he's a Nobel Prize-winning physicist, and he's written books that he doesn't think that you can create consciousness out of computational systems. You know, very controversial. But so I think that we need to think more about these kind of things, and how to detect it. And I'm reminded of an old story that, in fact, I think somebody told me this when I talked about detecting life or finding intelligence, that there was sometime a few decades ago, supposedly a policeman saw a person on their hands and feet under a searchlight or a street light looking around, and the policeman asked, what are you doing? And he said, well, I lost my car keys. And so the policeman said, well, let me see if I can help. And after about an hour, he asked the person, well, is this where you lost your keys? And the person says, I don't know, it's the only place I can see. So it's important to think about, okay, where did you really lose the keys, and how do we look there? But you're exactly, that's a perfect point.
Hello, thank you very much for that. I was wondering if you think that light sail technology will be used not only for interstellar travel, but also travel within our solar system, since it will eliminate using engines, which are dead weight on spacecraft.
No, absolutely. That was what we were looking at for using light sails, and even using lower powered lasers to push things around the solar system. But I'm quite excited about light sails. I think the age of sailing ships in space is upon us. In fact, I mentioned Arthur C. Clarke. He wrote a short story called Sunjammer many decades ago that talked about a race with people using light sails. But particularly in the inner solar system, where you have a lot of sunlight, I think traveling out to maybe Jupiter with sunlight makes a lot of sense. So I'm hoping there'll be more of it, the effort. NASA had a program which was put on hold, unfortunately, to use light sails to begin to explore the outer parts of the sun. But this, to me, is a very exciting effort, and I think it can be done very cheaply with pretty small systems. the Starshot effort is being continued, it looks like, at Caltech by the engineering school, and they're looking at light sails for a lot of different things. So, if you want to look at something that I think would be kind of cool to do that has commercial value, light sails in the inner solar system in the cislunar space make a lot of sense.
Thank you very much.
Pete, could we use light sails to have missions with human crew take a shorter time, shorten the duration of them?
Probably not. I mean, it's kind of slow, but I think taking cargo, like back and forth to Mars, makes a lot of sense.
Okay.
The closer you get to the sun, it's good. And in fact, if you wanted to go really fast, like I said, you'd get close to the sun, but I don't think human missions are going to fly within a few hundredths of an AU of the sun, at least near term. But we think we can make machines do that. But I think there are some uses for human missions that would be supplemented by light sails. I mean, another science fiction series was the For All Mankind a few years ago. That
Yeah.
they actually there was a race between a privately funded spaceship and a Russian one and a U.S. one, and the U.S. one kind of won the race by unfurling light sails that speeded them up a little bit. So I think there are supplemental efforts you could use light sails, particularly for slowing down when you come back to the Earth.
Okay, that makes sense.
Well, thank you for the lecture. What would you say are the odds that we'll discover life on another planet within, say, the next 20 years?
Boy, that's a good question. And I've a story. When we announced the SETI effort, the Breakthrough Listen, we did it at the Royal Society, and Stephen Hawking was there, and Frank Drake, who is sort of the originator of the Drake equation, the Astronomer Royal, Sir Martin Rees, or Lord Martin Rees now, and a number of other, Anne Druyan was there. And Yuri Milner said, what do you think the chances are that we'll find intelligent life in a decade? We originally started the program. And we went around the room, and most people said 1% or 2% or 1/10%. And so I asked Yuri Milner, who was funding this, who's dedicated over $100 million now to it, and said, what do you think? And he said 10 to the -5th. And to me, the interesting question here was that, if I went to the U.S. government, where I used to work for, and say I wanted to spend $100 million to look for something, and the experts said the best chance in 10 years is 1%, I'd be thrown out. But at least a philanthropist is willing to take that chance. And so that's an interesting area, but probably more to the point of finding any life. I think that's I would say better than 50-50 in the next decade. Intelligent life that might not exist or anything we can understand. But I'm pretty sure that we're going to find life in our solar system, whether it's in these ocean worlds or it's under the ground in Venus or Mars or in the atmosphere of Venus. There's enough evidence that looks pretty tantalizing. Or we may discover evidence of a life-bearing exoplanet. That's the other way to detect it. I think within a decade we'll have dozens of planets orbiting nearby stars that will have spectra of their atmospheres. We'll say, okay, this thing shows oxygen and water. This one shows sulfuric acid and phosphine or some other things, or something we don't understand. So I'd say pretty good, better than 50-50 in a decade. But intelligent life or technological civilizations, boy, that's a long shot. But if we found it, that would be the discovery of the century, if not of all mankind.
Thank you for the lecture. So do you have any examples of work that you've done or science that you've been a part of that has been used to create science fiction? And so then a further question would be, do you have any recommendations for us?
Yeah, I think, of course, we do science fiction. A lot of people in fact, people accuse me of writing science fiction in my science papers. But I remember, I was in the Air Force for 29 years. And I was actually involved in the Star Wars program, the missile intercept. And I was the director at Ames when there were these sort of asteroid defense movies. I think one was called Deep Impact, and the movie crew came out and talked to me before and a few others, and some of the things I told them were in the movie. So that was pretty cool, that it was actually sort of science fiction. I think the other thing is that it's more inspired by science fiction. I mean, getting to know Arthur C. Clarke was one of the great highlights of my life. I think science fiction is more an inspiration for us than vice versa. Now, I think the one that probably is most likely to end up in both science fiction and science fact is we have a major program to look for life-bearing planets, particularly in the Alpha Centauri system. I think we'll find evidence of something very interesting within a decade, as I said. And that begins because that's the star that we can say within maybe not our lifetimes, but not a lot longer, that we could actually send probes to and maybe even interstellar missions. So it's, I'd say that what we're doing follows up science fiction, it inspires science fiction, and ultimately inspires science fact.
General Worden, thank you very much for your presentation. You have a significant biodata behind you, and actually, is it possible also to explain us how you were implied in such project such as Clementine and other projects? And it would be really interesting for youth to refer to you and also to get to know about what were your experience and challenges that you may have encountered in fostering and sharing your knowledge and expertise towards strategic projects for governments.
Well, thank you. I mean, I can tell a little bit about it. For those of you in the theme day on dual use tomorrow, I'll talk about Clementine more. But I can tell you a little bit about Clementine. Was a mission that was done by the U.S. Defense Department. It was launched in 1994, and it was a project that actually originated. I was working at the U.S. White House and the National Space Council, and we were trying to get NASA to do it was the Moon Mars initiative that the senior President Bush did, and they were not very responsive. They wanted us to triple their budget, then they would have been responsive, and we wanted them to do it for a lot cheaper. And so I and another staffer there were bemoaning this, and we went over to a bar near the White House called Quigley's, and we were supposed to meet a congressional staffer who, like most congressional staffers, was late. So my colleague started doodling on a napkin, and we had been working with a Defense Department system for missile intercept called Brilliant Pebbles. And so on that napkin, we said, well, why can't we just go to the moon with this technology and do it cheaply? At that time, the head of technology at the Missile Defense Agency was Mike Griffin, who was a good friend of mine, who later became the head of NASA. And so he did a study, and then I ended up taking his job. And I said, well, we got this study, let's go do it. And I'll tell you tomorrow how we got it through the system. But that was the Clementine mission. It was basically a missile defense technology test. It half worked. It worked enough to orbit the entire moon. But I really got excited, and it has the first evidence that there's a lot of ice on the moon. So one of the things that I sort of fell in love with the moon. And so I've ended up actually doing 3 missions to the moon, or being involved in 3. The second one was LCROSS, the Laser Crater Observing and Sensing Satellite. Never picked such a bad acronym. That we actually impacted the polar craters. And you'll hear tomorrow that that's where I is actually at the final readiness review at the Kennedy Space Center. I was being a smartass. And they went around the table, and as they do at a readiness review, and everybody's in their coats and ties or formal outfits, and they start saying range, go, weather, go, launch pad, go, primary booster stage, go, and they get around, and the primary payload was Goddard Space Flight Center's Lunar Reconnaissance Orbiter, and so then they got to the secondary payload, which was LCROSS, and it was going to impact the moon. So I said, okay, these people are too serious. So I said, Ames is go for the first precision bombing run on the moon. It was kind of quiet, giggle in the audience, and so I thought that was kind of funny, so I put it on Twitter. That was a big mistake. And after I left that, the principal investigator takes me and says, "What did you say that for?" So I thought it was funny. He says, "No, it's going to get us in trouble." I said, nobody paid any attention. Everybody paid attention. And people put two and two together because Clementine, and there's a story about this too, they wouldn't release the data, so we sort of leaked that we'd found alien bases on the far side of the moon. So people assumed, okay, General Worden was involved in that mission, in this mission. This is a secret CIA bombing run on the moon to knock out an alien base. And somebody got a hold of my email. I must have got 500 emails that said that, please don't start an interplanetary war. My children are only 5 and 7 years old. Let them grow up. And then I got a call from the NASA administrator. It was Charlie Bolden, and he was really mad. And he said, I've got a congressman in my office yelling at me about the secret CIA NASA plot to bomb the moon, and you started this, and what'd you do that for? And I'm the administrator, not you. I said, I'm sorry, sir, that's the best you could do. But, we did bomb the moon, we did find ice, prove the ice was there, and sometimes it's important to have fun, but you have to take the consequences of getting yelled at by the administrator and almost fired. But I've been really fortunate in my career. I got involved in a lot of neat things. I think one of the pieces of advice is do things you think are fun. You want to have a job that you get up every morning and say, I can't wait to get to work. What we're going to find out or what we're going to do is neat. And don't worry too much about being fired. I mean, I've been fired about a dozen times. It hurts. You go home, you have a nice drink. Your friends feel sorry for you, but some of them stay away from you because they don't want to get fired too. And but then something new opens up, and so when one door is closed, others will open up, and just take it. And I've still got more stuff to do, so I'll probably get fired a few more times.
Thank you. I really enjoyed your talk. I was wondering, because you mentioned reviving Arthur C. Clarke through a large language model, I was wondering what kind of data did you use to train the AI with, and also did any ethical discussions come up in your group and with your colleagues when doing that?
Well, yes, and I mean, this was kind of a fun project. The other guy in that picture is a colleague of mine. He was a PhD in general relativistic theory, so he's a smart guy. And he had the idea that we could create avatars. And so what you do is you feed everything you have, books, articles, interviews, into the model. And then in the case of Arthur C. Clarke, we had met him a couple times and talked to him. And so you begin to interact with it. And you could ask it to write like Arthur C. Clarke. And we haven't yet, it's kind of complicated to create a voice model, but we're getting there. And so this actually became pretty good. I mean, I don't know if it would pass the Turing test, but it was close. Because when it greets you, it says, hello, Pete. I remember when we had dinner in Sri Lanka. And, so it's pretty good. And it gives me good advice on wines, and I know he liked wine. And but we then started to use it to bounce ideas off it. And if you bear with me a minute, one of the big ethical questions that you go to conferences and people talk about is what if there's life already on Mars? What's the ethics of us planting our life there? And that's very much an open question. And an idea came up that, I'm very interested in biology and space. And one of the ideas is that if you look at history of life on Earth, about 4 billion years ago, life emerged. But it very quickly diverged into two paths. These are called prokaryotes, they're simple single-celled organisms. But they diverged into, what differs is the chemistry of the cell coat between what are called archaea and bacteria. Now, archaea, there's as many archaea around as there is bacteria, but we didn't even know about it until 30 years ago because we couldn't detect the chemistry of the coat. And so this stuff lived for a couple billion years, and it probably interacted by eating each other. And somewhere around 2 billion years ago to 1.5 billion years ago, an archaea engulfed bacteria, and the bacteria wasn't destroyed, it formed a symbiosis. So the bacteria became what are called organelles. So eukaryotes, which is what we are, so in each of your cells is the remnants of those bacteria. They're the mitochondria, the energy-producing elements. In plants, they're chloroplast, the little, and what this did is it increased the amount of energy available to the cell by a factor of 1,000. The energy directly translates into complexity. So eukaryotes became very complex and ultimately evolved into all the species on the planet today, including us. And so I read about a year ago that a Japanese group had succeeded in taking chloroplast and planting them in animal cells. So, I mean, the idea was that you could have a cow that didn't have to eat, it would just stand in the field and green cow. And but to my mind, I said, what if there's life on Mars and it's single-celled? Is there a possibility that we could force a symbiosis where you maybe use an Earth cell and then you plant Martian cells as the organelles that, among other things, could handle the perchlorates that permeate Martian soil? And so our ideas that we didn't know about and made suggestions. So in the end, I thought his contributions were significant enough, so I called it him. And we wrote the paper, and we said, well, where do we submit this? And, Arthur was one of the early heads of the British Interplanetary Society. And there's a journal of the British Interplanetary Society. It's where he first published the idea of geosynchronous communication satellites. So let's submit it to them. And so we made it Arthur C. Clarke as a co-author. I think it's got Arthur Chat GPT, we called it. And they accepted it, and they wanted to use him as the co-author. And of course, most other journals won't because, as I said, a AI entity doesn't have, I think the word is agency. So it doesn't have responsibility, which is a legal problem. So the first thing we did is a few months ago, they said, okay, we'll publish it if you get legal permission. So we went to the Arthur C. Clarke Foundation in Sri Lanka. They have a lawyer in the UK, and they said, yeah, this sounds fine, you can use it. So we think this might be one of the first times that journals actually accepted an AI entity. Now, the question is, will it ever have agency or responsibility? And that's the question. But I thought it was kind of cool that on this particular topic, they were able to get a paper that might be one of the first that has a AI co-author that in a refereed scientific journal is particularly important because it was the journal that he was heavily involved with. So I don't know where it'll go, but I think it's a neat thing. And we keep feeding it more information. It's quite amused by this whole process. It helped us with the lawyer stuff too. We said, who do we talk to get permission to use you? And so he they thought it was pretty cool as well. And in the paper, it'll tell you how you can call up, I think you can just call up Arthur Chat GPT, and you can talk to it. Him.
Hiya. Is that on? Yep.
Yep.
Thank you for your presentation. That was awesome. I was just wondering, what is your opinion on the Fermi paradox, and also as a purely kind of philosophical sci-fi question, if there is life out there and they've actually observed us already, but they either can't or won't get in contact. What's your thoughts on that?
Well, the Fermi paradox, which I think probably most of you are familiar with, is that Fermi supposedly at a lunch somebody asking about aliens, and the question is, where are they? You know, if there's intelligent life and some of it should be much more advanced, how come we don't see evidence of that? That's a good question. And I think there's a number of potential answers to it. One of which is that complex life may be extremely rare. And maybe life is everywhere, but I just mentioned with the eukaryotes versus prokaryotes on Earth, that might have been a happenstance 2 billion years ago that if life other places it didn't happen. So maybe on Mars or Venus or in the oceans of Europa or Enceladus it doesn't happen. That's one possibility, that it's just very rare. I think a better possibility is that, from the other question, is we don't know how to recognize it. And one of the things, when I used to be in better shape, I did a mountain bike ride across Costa Rica. And I was with a British group, and of course, Brits like to drink gin and tonics. Not that I don't. And so we discovered that these sort of feral oranges that grow all over make really good gin and tonic, sour oranges. By the way, if you ever get your hands on them, gin and tonic with sour oranges are wonderful. But we'd had quite a few of them, and the hotel was kind of in the jungle, and as you might expect, the toilet backed up. So having had a lot of gin and tonics, there was a necessity to go out in the bushes. And so I went out in the bushes, and there was a tree sloth coming out of the tree. Actually, it does the same thing. It comes out of the trees for necessary purposes. And I looked at this creature, and it's a fairly sophisticated, mammal. It's reasonably intelligent. And you look in its eyes, and you can say, okay, this is like a dog or something that is pretty sophisticated. But it travels very slowly. And the reason for that, its metabolism is about 90 to 95% of what most other mammals are. And so the question is, to me, it's hard enough to recognize an intelligent animal that's moving slightly slower. What if it's moving orders of magnitude faster or slower? And there was a book written by a science fiction book by Robert Forward called Dragon's Egg. It was written, I think, in the 80s. And he sort of explores this. The science fiction concept is that there's a neutron star that's detected going close enough to the solar system that a human mission goes out and they orbit the neutron star. And they start looking at the surface of it, and they see little structures. And this is where the gravity is 1,000,000 times Earth gravity, and the temperature is 1,000,000 degrees, and so forth. And it turns out this is a life form based on the isotopes of iron, but it operates 1,000,000 times faster. And so the question was how to communicate with this, or how does it communicate with you? In the end, it figures out how to do that is through humans. And humans have some role because they started to dump the database down to these creatures, and they saw it as like Morse code every second or two, and they started to translate it, and it kicked their technology forward. But to my mind is, how would you recognize anything? If I couldn't even recognize an intelligent, mammal species that was intelligent, that was just a little bit faster or slower, what if it's orders of magnitude? And so the question is really, I don't think we know how to look. And how would it communicate? Would it recognize us? Does it even want to communicate? So that's the first possibility. The other one is that I think that we're going to find out about this is that what if we're just a phase and we become AI entities? Are we even interested in traveling interstellar? Do we explore new universes in digital reality, or create your own universes? This is the idea that we live in a virtual universe. So I think the truth may lie in those things, that either it's very rare, or it's very strange and may have very little interest in talking to us. Now, there's a third possibility that, okay, there's aliens that are here and among us and do things. Not impossible, but, I wouldn't bet on it. I wish it was true, but it's as far as I know, it's rubbish.
Hello, thank you for your... Stand up? Okay. Sorry. Thank you for your lecture today. I'm asking, something that I think you've touched on through all of your very extensive and interesting answers so far, but the question that came to my mind on the topic of science and alien life, often alien life comes up in science fiction, right? It's seen as a sort of may or may not happen, a very abstract thing, a thing of stories. From your time at NASA as well, comparing, do you find that the scientific community responds differently to scientific questions about alien life than it does to other kind of unknown questions in the space sector? Do you find that there's a difference in how seriously perhaps people take it or the motivation behind it?
That's a very important question, and we face that because we're spending a lot of money on an alien life question, the Breakthrough Listen particularly. And there's what's called a giggle factor, that, you know, when you talk about aliens or alien life, that a lot of scientists are sort of, no, that's all goofiness. That's people with tinfoil hats and so on. And it's taken a lot of effort with Breakthrough Listen to break it into a real scientific program. And part of our success is that we sort of stay away from, you know, what I would call sort of public sensation and speculation. In fact, one of the, Professor Loeb does the opposite. So, I mean, he is somewhat ostracized by the scientific community now, even though he was the chairman of the astronomy department at Harvard. And so I think there is a giggle factor, and you have to be very careful. We've also begun to be able to show that there's a lot of non-life science that we detect. When we looked for these signals, we've discovered a lot of really, interesting, phenomenon, the fast radio burst and so on. We're off. A lot of the discoveries there have been made on trying to look for these things. It also helps that we fund them a little bit too. But to me, one of the biggest successes on that, and this was a hard job, was to get Oxford Physics Department, one of the premier scientific institutions around the world, to actually say, okay, we're happy to host a technosignature effort. And so that's a success, but it's a lot of work. And we have to be very careful not to, I'd love to go to a tin hat conference sometime, but I have to go in disguise but I think there is a problem, and it's a psychological problem.
Hi, thank you for your talk. My name's Casey. I have two questions about the infrastructure related to Breakthrough. So you mentioned earlier that you're planning to set up multiple sites around the globe with small telescopes. I wanted to know about your process for site selection and how you go about consultation with local communities in the areas that you set up those. And the second one is related to the intentions to set up a ELT, and if there are any takeaways from the recent situation with the 30-meter telescope and how that went down.
No, that's a very good question, and I have to say my community hasn't done a very good job of understanding a lot of the ethical issues, and so we've had some conferences on that. But the way we manage this is, first of all, we set up a major program. It was originally at Berkeley, UC Berkeley, University of California. Now it's at Oxford. And we have a very senior advisory panel. The chairman of that was Lord Rees, who was the Astronomer Royal and the former head of the Royal Society. And so that's a community of astronomical experts. And they suggest, okay, this would be a good thing or that, and they review it for us. Then the second step is to actually approach those folks, and generally they're pretty positive. And in most of these cases, we're not building a new instrument. These are existing instruments that we do what we call a commensal program. And so let me use the example of one of the things we're very proud of. We have a major collaboration with the Square Kilometre Array in South Africa, and that effort was, we don't ask for any time on the telescope, so we're not competing with things. What we did do is we provided a rather substantial computing matrix that they can use for all their observations. And so we when they point the telescope, we just pull the data off. That we can virtually point an array telescope at different parts of the sky. While they're observing one thing, we can observe the other. So the first thing is to be a minimum impact. Second, of course, is that we try to fund efforts there. So we funded a number of student and postdoctoral efforts in South Africa. So it's clear there's something to be gained for them. I think the third question is the really important one, though, is when astronomers want to do new telescopes. I think we don't pay enough attention to, and I don't want to use the word indigenous, but traditional views that are there, and the way not to do it is the way the 30-meter telescope did in Hawaii. Even if you do that, you have some challenges, but I think from the start, the first thing you should do is if you want to put a telescope someplace, it's like I said, I probably should have talked to the government of Chile before I made an announcement. And they were very nice about it, and they're very supportive of astronomy. But it was that's a lesson that the first thing you want to do is talk to the people that are concerned, the locals and so on, and especially traditional efforts. I think other places have done a much better job. I visited the ALMA array in Chile. They worked very closely with the local community, including the indigenous community, and made sure they had a lot of support. Also, the Square Kilometre Array in Western Australia has done a similar thing. Very good job of working with the Aboriginal groups there, and I think that's a way to do it. Now, there's another solution, and this is one that I'm working on, is that maybe we should put all of our telescopes in space. And now, if we find aliens, then we have to ask them, I guess. But so one of the things I'm working on is to put like radio telescopes on the moon, large optical telescopes above the problem. I mean, one of our biggest problems now is Starlink for radio astronomy. It's pretty much ruining the sky for a lot of things. One of the things I hope to guilt trip Elon, so he'll help us pay for some of this stuff, but he's a hard guy to guilt trip. But I think that's a very critical point, that when scientists want to do something, don't assume just because you ask Professor Smith at the local college that's an astronomer, oh, is that all right? Yeah, that's fine. You need to spend a lot of time working with, okay, who are the stakeholders in this, and who should we talk with? And so there's lessons. I mean, there's lessons how not to do it and how to do it.
I think we have a question in the front.
Thank you for your lecture, and I have a question about interstellar travel. Do you think interstellar object like Oumuamua could be used as a natural probe of this space exploration? Has there been any serious attempt or possible things you think?
Absolutely. I think these interstellar asteroids are, first of all, if we could figure out how to rendezvous with them, and I think these sun divers I talked about, we can actually get high enough speeds, we could rendezvous with them and study them, because these are material interstellar. But I think the other thing that you allude to is these are going to go interstellar themselves again. Can we use those? And there was an interesting set of papers a couple of years ago. I was a co-editor of a special issue of Astrobiology, and we were thinking about the question of, did life on Earth originate from elsewhere? It's called panspermia. And the inverse question is, and this gets into an ethics issue, and we had a conference on this, what if you planted Earth life interstellar? I mean, is that, first of all, is it ethical, or can you do it? And we came up, there's a paper in there that I and Professor Davies at Arizona State and Chris McKay wrote that said, if we had one of these interstellar asteroids, could we nudge it a little bit to send it to another star system? Now, it would take tens of thousands of years to get there, but in the scheme of things, can you put probes or put even life on it? So the answer is that these interstellar asteroids are fascinating. And I think being able to first rendezvous one and maybe eventually use it to go to interstellar space is an interesting idea. And so I'm glad you mentioned that.
Pete, thank you so much for a fascinating conversation that covered a lot of interesting science this evening. Thank you to those of you who joined us online. We hope to see you again next week. For those of you in the room, we have another half hour here in the room. We can discuss things a little more casually.
Sure.
We can get off the stage.
Right.
So thank you to everyone for joining us this evening, and to our hosts at COFS and Hanyang University, and most of all to you. And also to the audience members who raised such interesting questions. You know, you all deserve a round of applause for that.
Thank you.